All right, let's start off on number 1 here. So this one we're wanting to write the slope-intercept form. So that's the y equals mx plus b. I always find the b first. I call that like the beginning. And so that's the y-intercept. So I can see the b there is -3. That's where it hits the y-axis. And then I need to find the slope next. That's the rise over run. I always kind of look first, is it positive or negative? So as I read this graph, you can see it's increasing from left to right. So it's a positive slope. And then I want to find like another good point here. So it looks like we got a good point there. So it looks like it goes up 1 and over 4 from that first point to the second point. So that would be 1 over 4. So our equation then will just be y equals 1 over 4x plus, oh, not plus, it would be -3. You could do plus on -3 if you wanted to. All right, next up, number 3 here. So for this one, this is a composite function. So for these ones, we kind of start on the inside here. So I'm going to do f of 6. So f of 6 means go to the f function and just plug in a 6 for the variable. So that's what I'm going to do there. And so that's -12 minus 4. And so that comes out to -16. All right, we're not done yet, though, because now we're going to do the outer function. So the outer function here is a g. And what I'm going to plug in there is like my answer from the previous question, from the inside, if you will. So I'm going to plug in a -16 into the g function. So it's going to be -3 times -16 plus 2. Let's see, -3 times -16. I think that'd be 48 plus 2. So that's going to come out to our final answer, which is going to be 50. All right, next up, we're going to simplify a radical. Now, the first thing I see here is that we have a negative inside the radical. Whenever we have a negative inside the radical, I just put an I out front and then make it a positive. We're dealing with the imaginary or the complex numbers here. All right, and so we break down the 200 now using a factor tree. You can go off to the right or you can go down if you want. Actually, I feel like I want to go down here, so it doesn't matter. So 200, I would think of that as 2 and 100. You could do 20 and 10 if you want, or there's a lot of ways to break it down. And so that's going to be 2 and 50, should be 2 and 25, should be 5 and 5. Okay, so then all the numbers I didn't break down anymore. I got to find twins. So it looks like I got twin 2s here. I have twin 5s here. And then I have a loner 2 right there. So that's all the numbers that I didn't break down anymore. So remember, the loner goes back in the house. So I'm going to have that 1, 2 back in the house. On the outside, the twins kind of combine as 1. So the 2 5s are going to combine to make 2. The 2 5s are going to combine to make 5. And I'm still going to have that I out front as well. So then I'm going to write this as 10I rad 2 as my final answer there. All right, next up here, we're solving a radical equation. Now for these ones, we want to isolate the radical first. On number 7 here, I'm going to add the 10 over to this side as my first step, because we've got to isolate this radical. -6 minus 2r equals -8 plus 10 is 2 now. Now I'm going to warn you here on number 8. On number 8, since that -5 is multiplying by the radical, you're going to want to divide that over. I'll just show that step here. You're going to divide by -5 as your first step on this one, because that'll cancel it out. So if it's subtracting, you're going to add it. If it's adding, you're going to subtract it. And if it's multiplying, you're going to divide it. Okay, but I'm going to continue with my problem here. So my next step is going to be when you isolate the radical, you want to square both sides. Now, when you square the radical side, it just cancels it out. So it's just whatever's inside. And then over here, you have to square this number. So 2 times itself is 4. From here, I just need to isolate the variable, so I'm going to add the 6 over. So -2r equals 10, and then I'm going to divide by -2, so I get r equals -5. All right, next up, we're going to multiply with some i's in here. So for these ones, what we do is I would always use a box for these. So you're going to put 2 minus 3i on one side, and then -5 minus 2i on the other side. If you put those in the other order, it doesn't matter. All right, so we multiply to fill out the box. So -5 times 2 is -10. -5 times -3i is 15i. -2i times 2 is -4i, excuse me. And then -2i times -3i is 6i squared. Okay, so I'm going to list my terms here, and I'm going to combine, I'm going to go -10 first. I'm going to combine these ones, and so that is positive 11i, so it's adding, so positive 15 minus 4. And then this one is 6i squared. But the thing we need to remember here is that I squared is always negative 1. So I always want to convert the I squared, if I have it, to a negative 1. So this is actually saying positive 6 times negative 1. Well, positive 6 times negative 1, we know, of course, is negative 6. So that I squared is always going to change the sign of whatever it's attached to, and it's going to go away. So now I'm going to combine like terms one more time. I have negative 10 and negative 6 gives me negative 16 plus 11i. We always want to put the imaginary numbers out back. All right, these ones we want to solve by factoring. Now remember that we first always want to get one side to 0, so I'm going to add 3k over to this side. I want to put this in order, so we're going to say k squared plus 3k minus 4 equals 0. And now we're going to do this. We got a times c up top, which is going to be negative 4, and b on bottom is going to be 3. So thinking of two numbers that multiply to negative 4 and add to 3 would be 4 and negative 1. So then we're going to use those numbers to split up our middle term here. So this is going to be plus 4k minus 1k, or just minus k. And we'll bring down these terms. We got k squared, we got minus 4. And then we will do the grouping here. I'm going to take out a k of this group, so it'll be k plus 4. Second group looks like we can't take out anything, but they are negative. So we're going to take out a 1 or a negative 1. So I'm going to take out a negative 1, which will flip the signs here and make that k plus 4, which is good because then we get the same thing in both of the parentheses. So then we have k minus 1 times k plus 4 equals 0. All right, remember we're solving now, so we have one more step here, which is to set these equal to 0 and solve. So k minus 4 and k plus 4 equals 0. So I will add 1 here, and k equals 1. And then I would subtract 4 here, and k equals negative 4. All right, next up, some more factoring here, some more solving. So this one we already have one side to 0, so I'm just going to go ahead and build my x. So we have a times c up top is negative 24, since it's 3 times negative 8, and then negative 10 on bottom. So we need to think about here what multiplies to make 24. It's a lot of ones, so we have 1 and 24, we have 2 and 12. Actually, 2 and 12 is going to work there. So I'm going to put a positive 2 and a negative 12. Okay. So we're going to split, and I put the negative 12 because it's got to add to a negative 10. So I'm going to put 2x and negative 12x there. So split up that middle term. We'll throw a negative 8 over here, and then 3x squared out front. All right, now we'll do our grouping. First group looks like it can just take out an x, which will leave me with 3x plus 2. The second group, these can both divide by 4, but since the third term is negative, I'm going to take out a negative 4, which is going to turn this to positive 3x plus 2. Which is good because we get the same thing in each parentheses. So I'll rewrite it as x minus 4 for the outside, 3x plus 2 for the inside. And then this is equal to 0, so we have that last step where we need to set them equal to 0 individually and solve them. So I'm going to say x equals 4, and then 3x equals negative 2. So x equals negative 2 over 3. All right, next up here, it says does a vertex, or does this graph has a max or min value? And I was already saying vertex because I was thinking about the vertex because that's really the main point here. And so you can see that this is the vertex is the highest point on the graph. It's opening down. This probably has a negative a value. I kind of know that because of the way the graph is pointing. And so anytime that happens, that means this is a max value. You can kind of see it on the graph is the vertex is the highest point, and the max value is always the y value, so the max value is going to be 1. All right, next up says find the x-intercepts. So for find the x-intercepts, we always plug in 0 in for y, and then usually we're going to factor. So we always factor when we're equal to 0, or you could use quadratic formula, but most of the time it's going to factor. And you can see we already have one side to 0, so that's nice. So I'm just going to do a times c on this side and b on down here. So two numbers multiply to 32 and add to negative 12. 32 has a lot of factors here. Let's think about it. We know we got 1 and 32. 2 and 16 is not going to work. It does not divide by 3. We got 4 and 8, and I think that will work. If I make them both negative, that'll multiply to a positive, but add to a bigger, so that's good. Okay, so I'm going to split up that middle term here. So we have negative 4x and then negative 8x. I did that in different order than I wrote it on the x. It really doesn't matter the order you write that in, so I'm not going to really stress about it. If you did it the other order, that's fine. So here we're going to take out an x. We get x minus 4. And then we'll take out a negative 8, which will give me x minus 4 as well. Remember, when you take out a negative, both signs switch. So we get x minus 8 times x minus 4 equals 0. But we are solving this for the x-intercepts here. So we have to set these equal to 0 and solve. So x minus 8 equals 0 would mean that x equals 8. And x minus 4 equals 0. If I added that 4, would be x equals 4. So those would be my two x-intercepts here. If I were to draw this graph, it would hit the x-axis at 4 and 8. All right, y-intercept here is actually a lot easier. Y-intercept, you plug in 0 for x. We saw that for x-intercept, we plug in 0 for y. But what's really easy about this, especially when it's in the standard form, as we call this, is that this one, 0 squared times 2 is 0. Negative 4 times 0 is 0. And so really, it's always going to be that last number, that c value. So in this case, that's going to be 6. If you didn't show that work there on number 19, if you just said, okay, I know it's the c value, it's 6, I think that's okay. All right, next up here, we're going to find the vertex. Now, this one's in standard form. So to find the vertex, we have to use a formula. We have a little formula here, which is negative b over 2a. And so this one is going to be, so we have a is negative 2, b is 12. And so I'm going to say negative 12 over 2 times negative 2. So that's negative 12 over negative 4, and that's 3. So we know the x value is 3, but we got to find the y value. So I'm going to plug this back in. We're going to take that x value we found, 3, and plug it in. We're going to use our PEMDAS here. So negative 2 times 9 plus 12 times 3. Do the exponents first. Then we're going to do the multiplication. All right. Now we'll add everything up. Let's see. Negative 18 plus 36 is actually positive 18. And then 18 minus 17 is 1. So my vertex is a point. It's the x value of 3, the y value of 1. There's my point. All right, next up we have some factoring here. I start off with perfect cubes. So I know it's perfect cubes because it's x to the third power. Also, I know 8 is a perfect cube, as is 27. So I'm going to make, for this one, it's a special pattern. It's always one small parenthesis and one big parenthesis. On the small parentheses, you got to take away the cubes. So 27 is 3 cubes, so I'm just going to put 3. And for x cubed, I'm just going to put x. 8 is 2 cubes, so I'm just going to put 2. Over here, I start off with the first thing times itself. So 3x times 3x is going to give me 9x squared. Then I do the first term times the second term. So that's going to be 6x, 3x times 2. And then I do the last term times itself. So 2 times 2 is going to give me 4. And then for the pluses and minuses, I use SOAP. So since this one was a plus right here, I do same, opposite, always positive. And that's it. All right, 25 here is 4 terms. So I'm going to use grouping. So we put the first two in a group and the second two in a group. The first group looks like I can take out a 3 and then an a squared. And that's going to leave me with 6a minus 1. So I do 18 divided by 3 is 6. And then 8 to the third, I take out 2 a's, that's 1 left. This one I took out the whole term, and whenever that happens, there's always a 1 left over. All right, so then these two terms, I can take out just a positive 2. And that leaves me with 6a minus 1 as well if I divide those by 2. And so that worked out well. We get the same thing in both parentheses. So 1 parentheses for the stuff outside, 1 for the stuff inside. We're not solving this one. It's not equal to anything, so I'm just done right there. Just rewrite it in the parentheses. Next up, number 27. This one I see we have GCF here. These are both even, so I'm going to take out a 2. And that leaves me with 4n squared minus 25. And then I notice that those are perfect squares, so I'm going to break it up into 2 parentheses. Perfect squares if they're subtracting. You can do take the square root of everything. So square root of 4 is 2, square root of n squared is n, and the square root of 25 is 5. And just write that twice. And then I just have 1 plus and 1 minus. All right, and then lastly, number 29. So we got a times c up top. For this one is a trinomial. There's no GCF, so that'll be negative 80. Negative 2 on bottom. Already I can see that's going to be 10 and 8 if I make the 10 negative. So I can split this up as negative 10v and plus 8v. And then I'll do my grouping. So the first group I can take out of v, which will leave me with v minus 10. The second group I can take out at 8, which will leave me with v minus 10 as well. So I got the same thing, so it's v plus 8 times v minus 10.